like that. So we were able to link the cones and the specific counties. That's why we have this particular cone. So I want you to copy the whole of this cone, the whole of it, the whole of it, the way it is. And also, that is in one chunk. Then another chunk where we are going to add this copy to be able to see the map of Kenya, where there were, these are what? Where there were malaria cases within the country.
Does it bring it?
No, you should not get anything the first chart. So the second one, you repeat and after the second one. So, sorry? Now, the first one, we needed because of the data, and we wanted to do the, what we call it? We wanted to match the code with the counties in Kenya. Remember, this training is about interacting with malaria data in Kenya situation. So we need to know how things are in Kenya. So with this data, I was able to do the, we call it the linking. Then after linking, you do the, after linking, you do the plotting, you create the plot. So this is the plot, and I can zoom to be able to see the malaria, these are positive malaria cases in Kenya from that particular data. So this is how the situation is. This is how the situation is. Malaria positive. This is positive malaria test results in Kenya. So you can be able to see which county. You can be able to see which county. See, this is map of Kenya. So you can be able to see the county with the largest. We call it largest what? Cycle. It has high number of positive cases in Kenya. Positive cases in Kenya. So you can see, you can see around Lake Victoria, there is high incidences of mosquitoes, disease, malaria disease in Kenya. Yes. Yes.
So where is the data for this? For example, if we say Mombasa, that dot in Mombasa is 50 cases.
Yes.
Where is that? Because I was almost immediately thinking this one, 2 or 2 cases. But then you say these are counts for counties.
No, those are the counts for the counties.
What is, for instance?
Like for instance, it is in the data, there is a data set that contains the number of cases that were recorded per county. So if the numbers are many, if you look at this code, let me go back. If you look at this code, this is the code. These are final malaria test results. So somebody was tested positive or negative. And there were a number of cases that were found in that county. They are represented by 1 dose. So if there were many cases, you will find that it's a larger dose. If you go to that particular county, you'll be able to see where all of them came from, that village. And I want to demonstrate it using this one. Let me show you. If, for example, I want Turkana, let me go to Turkana. You can double click there to see the number of cases there. If you continue pointing, you can be able to see where they came from, that particular village. It's just a village within that particular county. Not that answer your question.
Yes, but I'm asking, is this so is the data in the Excel file that
Yes.
you are calling malaria data?
Yes, it
Because
is.
that is what I'm asking.
Sorry, the data is there in Excel file, and it has all the documented cases for each county. Remember, we are dealing with, these are more than 4,000 cases, and each county has maybe, for example, each county has maybe 600 cases. Not all of them are positive. You may find that 80 homesteads and positive case of malaria. That is information that is being presented by the county. And then the dots is for that particular area, because they were not collecting the whole of the county. It is that particular pH. Let's say, for example, a pH.
So what I would be interested in is, if you don't mind,
Yes.
are there any requirements for this data to sit in Excel for the codes to see? Because that is exactly what will happen in a real instance. We send out someone to go and collect malaria data.
Yes.
For example, you are on an Excel. How do you now enter that data in Excel to make sure that it's compatible with this code? Because I'm sure if you send out people with Excel, 3 people, they will all enter this data in different ways.
Thank you. That's a good question. Now, this is what happens. We have gadgets that normally collect data. When you are collecting data, for example, you took at this point, you take code for that particular point at the time you are collecting the data. So if I found here there is a positive case here for malaria, I'll pick the data and also the code using that gadget. This is not data fetched manually by people. It is already collected using a gadget. Kenya National Bureau of Statistics, they use KOD gadgets. There are quite a number of gadgets which today they are collecting data. So once you collect the malaria data, we make sure you also capture the GPS data. So that data is there. It is a large data. I'll show you when I'm doing the model because it's the same data I'm going to use for model. Attention please for a minute. Now, the importance of this information is that when we run a machine learning model and we select the best model, let's say for determining the accuracy of malaria cases in Kenya, I will go ahead and try to establish the feature that is responsible for high cases through that particular machine. If I find it is, for instance, a region or a specific species of mosquito, I can be able to see which counties that particular mosquito is prevalent, or it's more common in that particular county. And I can be able to use the dot to know here there is Pasparum parasite. It could be maybe here in what? In Mandela or somewhere else. For instance, for Mandela, these are the positive cases. You may find that these positive cases is because of that particular parasite. So if you want to target to be able to know where to take that particular intervention, it becomes very easy to be able to know which place in Mandela. Look at it, it's very interior. It's very interior, but these are round. No, the name of that place. It's in Mandela.
Still in the town.
That's Mandela.
Still in the town.
But you can see it's towards the border.
That's where Malaria is.
That's where Malaria is. And those are, it's said true that this is where we have the high cases of positive.
Yes.
That's the place, eh?
Yes.
So what we normally do, like for modelers, we try to show that is where the problem is, so that the researchers can go and investigate. Why is this place prone for this particular disease?
I don't know whether whether I got the question right, but maybe just attached to that. When you have the data in a format in the Excel, is there a specific format that R can recognize?
No. Okay. Good question. R is a very nice software. It can read data in any of the database systems, whether data is in SPSS, whether it is in Excel, the normal Excel, whether it is in CSV file, whether it is in Stata, it can build all those sets of data. What you need, you install a specific package that will allow you to import the data in your app. So even the normal data in Excel, they can learn in Excel. It's very friendly. The way it was developed, it was developed in such a way that it can accommodate all the sets of data, provided you link to a specific package. Is that okay? Now, I'll still come back to this when I want to determine the key features that are responsible for these malaria incidences. So, allow me to see whether you have done something. Let us convert this document or render this document to HTML, PDF, or one document. So what do? Make sure you save. Make sure you save. After saving, I want to generate. I want to generate a document. To generate, you need, and I want you to need. You can first one need HTML, then later you need the Word document. If you want the Word document for writing the document, you can choose the one that you want. Choose the one. Choose one. There is no problem. So choose one. I can even choose one. There is no problem. Let's see whether it is. So the reason why I said I needed the console here, I want to see when it is being generated. So there is a problem somewhere, so I can be able to check where is the problem. So we did not choose one there. So let's try HTML. Let us try HTML. HTML. And see whether you get the results. I want us to generate the documents. We see the kind of the work that we have done since morning. Mark. Something. So this is the document. Anybody with a document similar to what I have? So this is my document. I hope you can see what I've generated. This is what I've generated. And what if you scroll this, we will go to see, hello, we'll be able to see the code and outputs is adjacent to each other. And this is what I wanted. 61, that's my case. So, so thank you. Any challenge anywhere? You should be able to generate HTML documents. So, thank you. With that, give me permission for 20 minutes. I do a presentation on machine learning. Then we try to do another code to generate the models. Now, this is very like wonderful. This one. Thank you. So I want to do a presentation on machine learning. Kindly, if you allow me, at least we have done something about So is everything okay? So I'm requesting for your attention for about maximum 20 minutes. I do a presentation on machine learning. Then I guide you on how to do the practicals. I demonstrate on how to do the practicals. For machine learning to be very easy, what is key is explanation of the results. No, don't close. Don't close R. What you do, I'll show you how to create another, they call it what? How to open another script that you're going to use for machine learning. Now, machine learning, by many definitions, is a subfield of artificial intelligence that focuses on the development of models capable of learning and making decisions or predictions based on input and data. This is what happens. We have these models which are already been developed, and what will happen, you subject your data to this particular, your models to a specific data. It is able to read that particular data and extract the patterns, the trends, the insights, and relationship that is there between the given data, and therefore it will be able to learn from that data and attain the ability that if it is given another set of data, it is able to make predictions. Okay? So, there is a relationship between artificial intelligence, machine learning, and I was saying there is a relationship between AI, deep learning, and machine learning. And within AI, we have machine learning, and within machine learning, we have deep learning. Yeah. So it's a subset. Okay? Machine learning is a subfield of the bigger family of AI, and then the deep learning again is within the deep learning. So all these are models that belong to what we call black box, like that. They are the models that belong to they are called black box models. Deep learning, this we use for cognizing scanning the images, and then through the images, the models are able to understand the patterns, such that if they find another image like that, they can be able to tell this is a cat. If it is subject to the features of a cat, if it finds another picture, it can tell this is a cat. I think we have another session where we'll be able to explain about deep learning. Okay? So these are, so in machine learning, we have three major. There are three types of machine learning. We have supervised learning, unsupervised learning, and reinforcement learning. The difference between the three is that supervised learning models trained with reported data. Reported data, we have what we call inputs and outputs. So we could be having this kind of the data, x1, x2, up to x3, and maybe the output is y. This is a reported data. That all these independent variables are tied to a specific output. If we have this kind of the data, we have what we call supervised learning. Then unsupervised, we don't have the output. It's only the inputs. Or we call it the independent variables or exponential variables. So we don't have the output. So we subject our models to this kind of the data, and it's able to predict the output for us. This kind of models are what we are referring to as unsupervised learning. Models training with unreported data. This is record data, this is unreported data. For this particular presentation or training, I want to concentrate on supervised learning and specifically the classification. Here is somebody who is tested for malaria. He is either positive for malaria or negative for malaria. So the data that we have, the output variable as is a continuous, no, it's a categorical variable which has only two outcomes. You are either positive or negative. So what will determine that the outcome is positive? Is it present of that particular parasite? Is it because we have not used mosquito nets? Or which factors are responsible for this particular outcome? Here it could even be the climate. Climate could also result to the positive cases or any other factor. We will see in the data. The models that belong to this particular classification are here. We have logistics regression, decision making, random forest, boosting, we have Kenyan, and also the support vector, machine, and many other that follows at these classes. Then we have under regression, we have this, but the good thing is there are some of these models which cut across the two type of prediction, either classification or regression. For instance, random forest can use for both classification and regression. If you go to support vector, can also be used for both regression and classification. Another important thing here to know is that under classification, one of the category is always the minor. If there is a disease in a location, the people with the disease, the number is always a small proportion. Is that true? When you are monitoring that kind of the data, you must be very, very careful. Because in many cases, you may end up with a model that is biased. Biased because everybody wants to be associated with the majority. Even in this room, if I pick 20 people, I place 5 people on this corner and 20 people in that corner, then a new person enters this door and they ask this person to join any of the group. Which group do you think the new person will join? The majority. And the majority don't have the disease, and he may be having what? Disease. That concept is very important, and we need to treat it with a lot of respect because it can affect our model. People want to be associated with majority, and the majority are what? The people with no problem. If you see the data is opposite, then this is not even an issue of model. To me, there's a big, big problem. Where out of maybe in a village, more than 50% of the people have the disease. That is what you call it what? Is it pandemic? That's a big public issue. But in many situations, we have a small population which has a problem. And this is the small population that we are doing research or modeling to ensure that the number is either compressed or eliminated completely to be left to the people with no problem. So these are the models. The other important thing in machine learning, when you get the data is split into two sets. The first set is training set. We have training set. And the other one is test set. Training set is the data that is used. Is the data that is used to train the model. Then the remaining 20% is the data that is used either to assess or to test the model to see whether it is working. Right together. There is also this aspect of test set. For our case, the validation set and test set we are treated as the same because the test set should be a new data. Should be a new data away from our data set that is coming in our system. And then we test our model with the new system, but with the new model. But for our case, we are going to have the training set and the test set. Once we have split the data, the other thing is cross-validation program. On trading, I'll share with you this. In fact, I've also shared with you this particular document. You can get it through the same folder. Yeah. So I've said you split the data into two sets. One set is used for training the data, and the other one is used for testing the data. And the training data, in most cases, takes about 80%. Takes about 80% of the data set. This takes about 80% of the data set. Then the testing, about 20%. Why? Even when we teach students, we teach them for about 3 months. For gain knowledge. Then we give them an exam that they are going to do for only 2 hours. So you spend more time training a model, then you test, you see, as more sets of data to see whether it is working. Sasa? Then from there, Once you have split the data, there is a concept of cross-validation. This is a powerful statistical technique used to assess the performance of the model and generalization ability of the machine learning model. Remember, this is a model that you are training and gain that knowledge. You want it to behave like, brains of a human being. You want the model to think the way human beings' brain work. So it has to be it must have that ability to generalize the features and the patterns that are there in the data. It helps to ensure that the model generalizes well to unseen data by testing it on different subsets of the data. Now, this is the catch. If we don't cross-validate the model, this cross-validation, this is what will happen. The model